Hi, in this video, let's see how we can see the machine learning model. So let's start developing a machine learning model and then let's save it. So for the data set, let's go to Kaggle hard disk data set, click on the first link here and scroll down under the data card section. You can see this hard.csv file. Click on the download symbol. Terminal, if in case if you're using the Windows, you have to click on the command prompt and run this one Jupyter notebook. This will open the Jupyter notebook for you. And here, let's import the file. Click on upload, whichever the download. Click on hard.csv. Select this file. So we have successfully imported the file. Click on rename and save the file. And now let's create a new notebook for this one. How to save how to save ML machine learning model, right? Click on here. Instead of code, I'm making it some markdown for the header. First, import data, right? I'm clicking on shift enter to go to the next cell. You can see here. If in case if you want to delete this cell, select this cell and click on D for twice in quickly. It will delete the cell, right? Or if in case if you want to create a new cell, click on at the edge and click on B. I always prefer this low memory is equal to false, so that all the available memory will be allocated to this notebook whenever we are running. So df.head, so we can see this one. So basically this data is um, talking about whether a human may get the heart disease or not. They are like 1 2 3 4 5 6 7 8 9 10 11 12 13 input features are there. So in machine learning terminology we call it as a features. We can also call it as inputs, whichever is feasible for you and comfortable for you. And the target is or the label. In the machine learning terminology they call it as a label. Let's see what is the count of this data set. It's 1025 rows and 14 columns. So 14 columns and 1025 rows. Let's quickly check for any blank cells. Df dot replace this one np dot nan. I'm replacing with nan values, not a null number. In place is equal to true. Basically this helps us to save this one. So what we have done, we have replaced the blank values with none and we have saved that one. And look for the nan values, I mean the null values. Any null values, okay, there are no null values, which is really good. And if you wanna see the data types, let's quickly all either integers or floats. This is really good. And if you wanna see the statistics of this one, you can see what is the count, what is the mean value. So the mean is that here the average age in this data set is 54 and the deviation from the mean value is 9 and the minimum value is 29, maximum age is 77. This is good. Now what I'm going to do, let's split inputs, or we can say features and labels, right? So we have this one, right? So what I'm going to do, I'm going to assign a variable to all of these columns and another variable to this output column. For example, input as x, df dot drop. Instead of adding all this column one by one, I'm just dropping this column here and assigning rest all the columns to this x value. So columns is equal to target. So because we are dropping an entire column, we have to put axis is equal to 1. Y is equal to df. I just need the target column here, right? So if you wanna see how x looks like, let's see how the first two values and let's see the white first two values. This is good. And now split the data. So what I'm going to do, so we have like 1025 rows, right? So I mean, um, I'm going to use few of these records to train the model and rest of the records to test the model whether the model is predicting the values or not. So for that, I'm going to split the data. One more thing, whenever you create a cell, if you want to use it as a text format and all, click on here and go to here and click on markdown. So it will create a text for you instead of the code. So split the data into training data and test data, right? So this is a markdown here. So I'm just making it as a code. We have to import this From sklearn dot model selection module, for this one import train test split. You can use this one random dot seed 42. Basically, if you use this one, the way it splits for me, the same way it splits for you as well. X train comma x test y train comma y test is equal to train test split x comma. So we have x, we have y. What's the size of test data that I want? I'm going to take 20%. And either you can put this np.random.seed 42, or you can give some number here, a random state. Either one you can do is equal to 42. You can give any number. For example, if I put like 27, and also if you put like 27, so whomsoever uses 27 here, the split will be the same for them. So I always keep like 42 only. This is the one. So let's execute this one. Now let's see what's the shape. I mean, what is the value, and y train dot shape. So 822, for the 822 rows are assigned to the training data. Let's see for the text data, how many are assigned. Okay, 205. So how you can see, for example, length of total length data set is 1025 into 80% for the training data set. You can see 820, 820 here, and length of df into 0.2, you can see 205, 205 here, this one. Oh, this, so far this is good. And let's import the machine learning model here, ml model. So we have like so many modules, and as is one of our beginnings videos, and also let's go ahead with the random forest classifier. Why classifier and not regressor? If you look here, sklearn map, go to here, and let's go. So let's start. So we have more than 50 samples. We have like 1025 records. This is fine. We can go ahead. Predicting a category, is it, I mean, actually this, yes, it should not be here. There is a mistake in this one. It should be from here actually. So just remember, note this point. So predicting a category, so if it is an S, it's a classification category, in the sense like 0 1, something like that. If in case you are predicting the price and all, I mean, if we are not predicting a category, if we're predicting the price, and also we have to predict a quantity, and from here the S should be there. So as we are predicting a category, we have to use one of these models, and the classifiers are here. And how do we know whether there is a classification model or a regression model? And let's go here. What is the target? Targets this one, right? So let's see. So df dot head, I'm just taking, so df dot target dot value counts. So basically this gonna give like 0 and 1 and 0. Basically these are like the predicting the categories, not the quantities in the sense like predicting a house price or predicting car price, etc. These are discrete values, 1 0 something like that. Continuous values like house pricing and all, they are the continuous values. And this is good. The same, the I mean, this one we can also, I mean, few people they prefer to write like this one. It's up to you how you wanted to write. Right, this is good. And now let's import the machine learning model. I'm going to use from sklearn.ensemble import random forest classifier. Okay, instead of writing this random forest classifier every time, I'm just going to make it as rf is equal to random forest classifier. So n estimators is equal to 100. Basically you don't have to put this one, but ideally this is default value. So 100 means random forest means, I mean, this is how it looks like. Random forest classifier, if you go here, if you go to the images and all, you can see like lots of trees and all. So if you put like n estimators is equal to 100, basically it is going to um, generate 100 trees, and whichever and so I mean, look at this one, it is going to generate 100 trees, and then it does the majority voting, and whichever gives the better accuracy, it takes that value. So these n estimators, you can take like 10, you can take like 100, as per your wish. I mean, as per, not our wish, as per the accuracy of the model. Okay, so just rf, you can see the random forest classifier. This is good. And now rf dot fit We have training data, right? Y train. Okay, we have fit the data. Now let's see what is the score. Score is nothing but the accuracy for the training data. It is one. One is like 100%, which is good. Why it is 100% here? Because we fit this training data to the model. So basically, the model did understand about this data. So that's the reason it gave like accuracy like 100%. But now let's see the score on the test data. Test data is something that the model have not seen so far. So Y test, oh, it is like 98%. So basically, out of 100 records, 98% of the times, I mean, the model predicts like accurately. This is really good. And now, um, let's see how we can save this model, right? Save model. So for that, let's import this model called Pickle, right? Pickle, comma dump. What is our model name? RF, and then open. Give any name. I'm gonna give like random forest classifier Rajiv.pkl, and we are writing this one. So wb. So this is done. Now let's load this one. Pickle.load. I mean, this model is downloaded. This model is saved. Let's go. Yeah, you can see your model, the saved model here. .pkl represents the pickles which are like saved ones. And I mean, once you save the model, going forward, instead of running all these columns at a time, so what we can do, let's import that model. Import model. So pickle.load. Open. What is the model name? Random forest classifier underscore Rajiv dot pkl. It's read book. That's it. We have loaded. So I mean, instead of writing, I mean, I'm going to assign a variable loaded model, right? And this and dot score x test y test.